This is MAP4C day 15, lesson 2.3b, optimizing areas and perimeters. The last day we solved problems involving the optimization of perimeters and areas, and we'll see, yesterday essentially we're just after a square, and we'll see today that not always are we after a square. So in several sort of situations. But 3-minute review question: you have 180 meters of snow fence to enclose a space for a snow derby at your farm. What dimensions will maximize the enclosed area? Well, notice we can go after a square, can't we? Fencing, we can have parts of meters and all this other business. So 180 meters of fence, it's going to be a square. And this one, we're given the 180 meters around the outside. So we know x and x and x and x. 4x is 180. Divide by 4 on each side. X is 45 meters. And so we say, therefore, the max area is given by a 45 meter by 45 meter square. And just for comparison's sakes, I'm actually going to find the area of that square. X times x, length times width, 45 squared. And that is 45 squared is 2025. Because today's lesson, that's it for the 3-minute review, today's lesson is, answering these what if questions. What if it's a triangle? What if it's a circle? What if we only had to enclose 3 sides? Those are the questions we're answering today. Same expectations as yesterday, but it says from the 3-minute review, the maximum area would be a square. The best shape is a 45 meter by 45 meter square. Return to the problem in the 3-minute review. So this is the snow fence problem still. What if it's a triangular area? Why you would make a triangular snow derby area, I have no idea, but let's just say. So, and remember the area was 2025. Keeping that in the back of our mind. What if it's a triangular area? Well, I think it wouldn't be too hard to convince you, because a square is the best 4-sided shape, that equilateral triangle is the best triangular shape. And I'm just going to assume that I can convince you of that. And so what do we got? We've got the 3 sides of the triangle have to be 180 meters. So divide by 3 on both sides. Each of these sides is 60. And if I want to find the area, notice, because I want to see maybe the best shape isn't a square, maybe the best shape is a triangle. I want to find out what the area is. Well, if this is 60 along here, 60 there, 60 there, to find the area I need the height, right? Well, how do I find the height? I can see the base is 60. The height, well, I have to use the Pythagorean theorem, don't I? Good old Pythagorean theorem again. There's the height. This is half of the base, which is 30. And then I can use the Pythagorean theorem, question mark, to find the height. Hypotenuse squared equals h squared plus 30 squared, 3600. And I know some of you aren't very comfortable working with these algebraic equations, but hopefully you have enough skill that this isn't so bad. And if you know you need more help with that, what is that? That's not 2,500. It's 2,700. Later in the course, we'll be doing quite a bit of algebra work. So if you know you need to get better at your algebra work, we will practice. Square root of both sides here. That's the step. Square root both sides, and that's about 52 meters. And so I can find the area. 60 times 52 divided by 2, which is about 1558.8 meters squared. And notice that for the same amount of fence, the 180 meters of fence, we're getting a lot more area enclosed by using a square. Best triangle, 1500 and change. Best rectangle, which is a square, 2025. What if we had more sides? Well, actually not more sides. What happens if it was circular? Right? So somehow we'd set up this fence in a circle, and we'd know that then the circumference around the outside, the circumference of the circle, is 180. Wow. Instead of solving for x, the side of a square, I got to solve for r. I don't know what the radius of this circle is. So how do I get the radius alone? I've got to divide by the 2 pi. Divide by 2 pi on either side. Now when I put that into my calculator, divided by 2 pi, I'm going to use brackets there, okay? 180 divided by bracket, 2 times pi, bracket, use your pi button, and you should get about 28.65 meters of big circle. And then let's figure out what the area is for the circle. Pi r squared. The radius is what we just found out, 28.65. And I get an area of, unless I made a mistake on my calculator, about 2578. And notice what we had. We had the triangle was about 1500 and something. 1500 and something. You know, I don't know, can't remember what those numbers are. The square was 2025. And now a circle is a lot better. So if you could make it any shape, you should make it a circle, because overall, the circle's better. Even better than the square. Sometimes it's not practical, and sometimes we're after a rectangle just because it's easier to make rectangles. Like this one. What is the area? What if the area is against the house and only needs 3 sides to be fenced? So this is the house, and I'm going to put the snow derby area next to a house. And of course, I wouldn't need fence along there. Okay? Well, not sure, but it makes sense that we should be able to fit in more area, right? Because, you know, I'm kind of using this as an extra side of fence almost. So I should be able to get an area that's even bigger than the circular area, because I'm using the house as an extra side. So how we do these ones is we got to set up some sort of table, okay? And I'm going to pick the width, figure out what the length must be, so that, remember, I get a 180 meters of fence used. Okay? 180 meters of fence is kind of still my constraint. And I don't know, maybe a square still is the best shape, but I'm going to use a table to sort of investigate that. And I'm going to start with a silly one. I'm not going to use 1 meter, because who has a house that's 180 meters long? But I'm going to use 10. Okay? So notice, if I have this as 10, I also have to use 10 over there. How much fence is left for the length? Well, I'd go, you know, 180 minus 2 times 10, the 2 widths. I've got, well, 160 meters left for the length. And who has a house that's 160 meters long? Well, we're pretending now. Area is just length times width, 1,600 meters squared. And notice already that's better than the triangle. But let's keep going. What happens if this is 20? The width is 20. Same little calculation over here. 180 minus 2 times 20. And this, probably you don't have to do the work on the side here. 20 and 20 there. I know I've got 140 left over for the length. Multiply those two to get the area. And how do I know when to stop? Well, hopefully I'll get a clear indication what the best shape is. And I'm just going to follow my table here. 180 minus 60, 30, and 30 here and 30 there is 60. 180 minus 60 is 120. That gives me an area of 3,600. 3,600. And notice these are going up, so this is good. I'm getting better and better shapes all the time. 40, I got 180 minus 2 times 40, that's 100. So if this is 100, and maybe, just maybe, you're seeing a pattern here. This is going up by 10, this is going down by 20, which makes sense. I'm using an extra 10 meters here and here, so that means the length has to go down by 20. And I'm just going to keep going. Still going up. But here, something pretty neat happens. 50 there, 50 there. 180 minus 100 is 80 left over. 50 times 80 is 4,000. And notice that now they're going to start going down. And I'm not going to do the 61, but it looks like there's some shapes in here that we're missing, some possibilities, right? Maybe something in here is the best shape because it's going to keep going up, get to a maximum, and then start going down. So what would be the one that we would try? Well, maybe I'd try it halfway in between. Sure, I will. I'm going to try 45. So if this is 45, this is 45, I've used 90, I've got 90 left over for the length, and then I get 4,050. Slightly better, and in fact, that's the best shape that I can do. You can try other ones, but you're not going to get better than that. 45 meter by 90 meter shape is the best. And if you notice that, hopefully you see something between these numbers. This length is twice as much as the width. You see that? The length is twice the width in these three side ones. And that's true. And you might have remembered doing some of these questions earlier. Okay, let's keep going. Another what if. See what if? What if there's a 2-meter gateway with no fence in the middle of the longer side? It says stick to rectangles here, all 4 sides are fenced. Rectangles, remember square is a special rectangle. So what are we talking about? We're talking about, okay, if I have a shape like this, all 4 sides fenced, but in here, there's 2 meters with no fence, right? Where I don't need the fence because there's a gateway put in there. I'm going to call this the width and this is the length. And it's not real clear what the approach would be. So again, I think I go back to a table. Your hint should be, you know, maybe this should be a square anyway, right? Because a square with an extra 2-meter space would still be the best shape, wouldn't it, if I have to go all the way around? And in fact, that's what we're going to find. Now I'm going to leave some space over here to do a little rough work. Area, again, remember, I've got 180 meters of fence to work with. And again, I'm just going to pick the width and calculate what the length has to be. Now this is going to be weird because of this 2 meters. 10 here and 10 here. So 180 minus 2 times 10, that's 160 meters I have to work with. But notice, I've also got these 2 meters for the gateway to work with. So it's kind of like, instead of 160 meters of fence, I kind of have 160 plus 2, right? Because one of the lengths is going to have an extra 2 meters. So essentially, I'm going to go 162 and then divide that in half to figure out how much fence goes on either side. That's 81. And then I multiply that. That's no problem. And I just want to explain why that makes sense. Notice if this is 10 and this is 10, this is 81 and this is 81. Well, how much, what's the perimeter? 10 plus 10 plus 81 plus 81 is 182 meters, right? 81 plus 81 is 162 plus 20 is 162. But that 2 meter fence I could take off. So how much fence do I have? I have got the 180. That's why this where this extra 2 meter comes in. And now I'm going to keep working. Same thing, same calculation, put in 20 here. 2 times 20 is 140. But actually I've got 142 because of the gate. I've got 142 meters because of the gate to work with. That's 71. And then you see a pattern, right? This goes up by 10, this goes down by 10. That's 14, 20. I'm just multiplying length times width there. And on I go. You could check these if you'd like. 1830, 2040, 2050. And again, these are going up pretty fast, and then suddenly this one is almost the same. Again, we're going to think maybe something's going on right in here, halfway between, and that's what I'm going to try. So if I go 180, subtract 2 times 45, that gives me 90 meters. But I really don't have 90 meters for the two lengths. I've got 92 because of the gate. The length is actually 46. And again, this is pretty close to a square, and this is a little bit better than the ones that we've got. How much would we have to fiddle around with this to get it to be perfectly square? Well, who knows, but, and I would never expect you to think this way, but I'm setting you up for soon, lesson soon. If I let the x, then, well, I could just use this calculation. Then the length is going to be 280 minus 2 times x, you know, and then add 2 to that, add 2 to that, and then divide that by 2. Well, that's pretty complicated, but that's essentially what we were doing. We might be able to do something like this in a spreadsheet, right? This spreadsheet seem like they would be really good at this. And that's what we're going to be working on soon. But, conclusion, shape is probably a square. But once we've listed a few, we're just going to pick our best shape that we have. Done. Homework time.